Hello and welcome to our first session, day 2, on the data science track. Thank you all for coming to PyData Global. I hope you have a great day. I'd like to introduce our first speaker, Hansila, who will be speaking about PyData Bloom Framework, a multidisciplinary approach to data science in university education. Without further ado, I will hand over to Hansila.
Much for your interviews. So we share my screen. Okay. Hope you can see my screen. Today we are going to talk about a new thing, not only about the technical stuff. Sometimes I think all of you hear about technical stuff, all those things in this session. So I will welcome all of you to my session. This is something new related to data science and university education. So greeting all of you. This is my topic, PyData Bloom Framework, a multidisciplinary approach to data science in university education. So here actually I need to bridging the gap in data science education across disciplinaries. I mean, I want to cover all the multidisciplinary areas related to data science. So about me, I'm Hansila Sudasinghe. I'm a lecturer in computer science in Anaconda University, researcher learner. And if you need to contact me, this is my personal email. And this is my outline. I'm going to talk about this in this session. And so when you come into data science as data scientists, yes, we know what are the opportunities, we are going to update those things, we are doing researches. But overall, do you know, when you go through, actually I had done some kind of research. So currently trending 80% of jobs now require data skills. So when you think about our overall university education in multidisciplinary education, so it's just covering related to data science very small fraction related to in our university curriculum. And also as a lecturer, so I'm just saying, yes, I'm conducting different type of workshop session to computer science students. But also other people, the other students from multidisciplinary, just like bioscience, business management. Sometimes they're asking about me that, so what is this data science? Can we learn that thing? We need to learn that thing because especially they are using traditional approach to just like SPSS Minita. Sometimes they haven't the idea how to do those things related to data science using programming languages. Sometimes they have idea, but they haven't time actually. Sometimes they are in a fourth year. So and also they don't know what is the path, what is the correct way. So there's a challenge nowadays when I, as a lecturer, as the person from academy, I just seen that there's a gap in data science education related to multidisciplinary area. So there's a lack of interdisciplinary science in curriculum, data science curriculum, and also, especially, I'm not going to criticize. The thing is, when I'm going to compare with technical students and non-technical field students. So non-technical fields, they are currently struggle to access and use of data tools effectively. And our have seen that there's some kind, when you come to overall, not only particular education system or university, there's an imbalance in curriculum designing. When you come to traditional curricula, sometimes it's too generic or sometimes too advanced. That means interdisciplinary people, when you come to related to business, humanities, art, whatever, sometimes they cannot grab. Because when you come into too advanced means yes, sometimes I can say, yes, there is a good curriculum, but within short period, they have to grab all those things. So overall, it's very advanced, and especially when you come to beginners or non-specialists, they haven't time or they had the path how to grab those things. So this is the significant gap between that student and learn than what they need real world scenarios. I just identify there's a gap between today when you come to especially multidisciplinary area. So that's why doing some research work, I have introduced this new framework to our PyData Global, PyData Gloom framework. So this is covering, I just grabbed mainly 3 areas: Bloom's taxonomy, knowledge discovery in database, what you are known as KDD process, and related to Python techniques and tools. I told you when you come into traditional tools, but we know I will come to that point. We need Python and also apply Bloom's taxonomy and knowledge discovery. So actually, this framework is not only only short course. Actually, when you especially I focus at university education as an undergraduate, especially related to honors 4-year degree. How we can make a pathway to any person from any disciplinary area, the correct way, and how to build a good curriculum using these 3. So what is this Bloom's taxonomy? So it's very popular when you come into education field. Some of you may hear or not. It's a hierarchical framework we are using to classify learning objects. So this framework actually originally developed by Benjamin Bloom and team of educators in 1950s, this area. And now we are currently widely used in education field, especially when you're coming to such as set up designing curriculums and learning outcomes or assessment method. So all this we are following this Bloom's taxonomy. So we have actually from 1950, now we have revised version. Basically, there are 6 key areas in here, 6 key stage. From when I discuss from bottom to top, actually, first we can see, you can see Bloom's taxonomy words: remember, understand, apply, analyze, evaluate, create. And I think you can see in your left hand side in this picture the meaning, and there are some keywords how we are going to apply in education field. For example, remember. Remember means something we can recall. Actually, we are testing from students. Are they going to recall facts? And they have that understanding about remembering about basic concepts. So how we can check using, especially coming to practicals and written assessment exams, we are using basically some kind of keywords. For example, define this thing. List some kind of area, list down those things. And second, we have understand basically covering up explain ideas or concepts. So here we are using basic type of keywords. Discuss this term, explain this one, identify what are those things we have to use for this one, or reporting. And next we have apply. So under apply, we are trying to from student part trying to get using how they are use information in new situation. For that, we can see the keywords. Demonstrate this, especially come to practicals. Demonstrate this thing, implement a project or something, and analyze. We are focusing draw connection among ideas. So here we are using basically, you can see different kind of keywords, test questioning, compare and contrast, compare with this one and this one, identify, differentiate those things, do experiment. So we are using, related to analyze, we are using these keywords. And when you come to evaluate, we need to, from student side, we have to identify how they are going to justify a stand or decision. So the basic keywords we are using: argue something, judge, support for this statement. You have to support for that. Finally, top of our Bloom's taxonomy, we can see create. So this is related to produce new or original work, 100% of new work. So in this, we are applying keywords just like design, assemble, construct, develop, formulate. I mean, especially come to research project, those things. Yes, we are applying those keywords. So sometimes you may ask, how do Bloom's level align with our educational goal? So I'm just explain here. So my main focus is designing 4-year Hans degree. So we can actually align those Bloom's level with our education years. For example, we know when you come into new undergraduate, what you are referring of foundation year, first and second years. So always they are trying to remember. So we are covering remember and understand level basically related to Bloom's level. So here student build a foundation knowledge and memorizing those things, basic understand. And come to middle level, we are considering third level. So yes, we can apply from Bloom's level, apply and analyze. Mean that stage, third years, yes, students start to solving a practical problem, just like analyze case study, develop some kind of critical thinking. And when you move to fourth years, now that means final year. So basically, when you come to Bloom's level, we are targeting evaluate and create. So always as academias, we are providing research project, individual project, or sometimes original solution for some new innovative things, and come to independent judgment. So mainly focused. So you can see how you are going to align Bloom's levels with educational goals. And so how we can apply to this data science? So go through with Bloom's taxonomy and data science. For example, we can use those taxonomy. For example, remember syntax. Sometimes library function related to Pandas, NumPy. How we are going to use it and understand it. For example, interpreting a data output or data visualization and apply. Writing some kind of Python script related to pre-processing, analyze this data. So we can use that kind of applications. Analyze. So we can ask from student comparing some statistical models, this model and this model or data pipelines, and come to evaluate. So now in analyze stage, yes, student level, they have already used some kind of model. So we can ask assessing model, evaluate using performance metrics. So then we have create finally. I told you when create mean building own solution, a new thing. So here we can apply as building end-to-end data solution. So then I will move to next main part. Another part I told you when you come to this my new framework, we have KDD, knowledge discovery in data science process. As you know, it is very popular thing, KDD process. We are using identified novel and potential useful understandable pattern from large amount of data. So in simple terms, yes, if we have raw data, we can transform into valuable knowledge. So basically we have 5 stages in here. As we know, yes, we have first raw data, we have unclean data. From that, we have to do data selection. That means we have to identify extract relevant data from available data set. And then we have to do data pre-processing. So that means we have to clean data, We have to handle missing data, noises, inconsistencies, all those things. Then related to transformation, now we have select our data, we have done data preprocessing, then we have to transfer our data into suitable format for analysis. So for that, we have to do normalization, aggregation. Also, especially we have to perform feature selections. And when you come into data mining, finally, yes, we have to apply related algorithms and techniques. We have to identify what are the techniques and algorithms we are going to apply. For example, whatever clustering or classification, and we can do uncover patterns. We have to identify uncover pattern and relationship of our data set in hidden knowledge. Then finally, using these used methods, we can evaluate about our data patterns and model using FI scores, recall, those things. So then finally, yes, we have our target, knowledge. So knowledge is our application. This is very useful for when you come into if you have large data set, knowledge the thing we have to make decision how we are going to apply those things. So also I use this KDD process in my new framework. Next, also another major area I told you, I use Python. Why? As we know, yes, when you come into data science, it's very popular. We are widely applied, and when you're comparing more other languages, programming languages, we have ease of learning and use, and we have strong data handling libraries, just like Pandas, NumPy, just like those things. And other case, especially integrated with other technology integration. For example, Anaconda, Snowflake, Google Cloud, those things. So we have so many flexibilities work with other technologies. And other than that, yes, we have large and actual community support. It's very helpful. When in issue or trouble, we have good support. And also there are many more, for example, dynamic data handling those things. So I select Python as my basic tool when you come to, so we are talking about PyData Global because of those reasons. This is my framework, what we are calling PyData Bloom framework. So basically, you can see there are three things. The middle, you can see Bloom's taxonomy, basically the revised version, the 6 terms. And left-hand side, you can see year-wise alignment. And right-hand side, Python curriculum. So what I have done, I just get Bloom's taxonomy and I have aligned with year-wise review, and I just build a new Python curriculum to multidisciplinary students. So this is, and also this is applied I just consider for 4-year degree program. So basically, when you come to year 1, we have to, so under remembering, I thought to cover basic programming, because now I told you this is for multidisciplinary. That can be student from art, humanities, business, dancing, whatever. So we can add to our curriculum, Python curriculum activities, the introduction to Python with Google Colab, basic introduction. When you go into middle of the year 1, semester 2, so we can add in our curriculum foundation for data manipulation. As example, we can add in our Python curriculum, we can add basic data manipulation in Pandas, numeric operations, NumPy, just like that, the basic operations. Now student climbing ladder, student now in 2nd year. So we can apply. Applying this one, we can add practice data cleaning and visualization with KDD. So here, we can apply data cleaning and visualization, some kind of data cleaning, pre-processing, and visualization part with Pandas and Seaborn. And when you come into analyzing, yes, year 2, just like second semester, we can use the basic static analysis. Basic static analysis using NumPy or data analysis. And moving forward, when you come in, the student coming to third year, we can give a EDA process. So we can provide in curriculum, we can add some activity related to analysis, mini project, Google Colab, and EDA with Pandas and Seaborn. Third year, just like when you come to middle of third year, second semester, just like that. So we can add critical assessment of data modeling and real world storage. So when you come to this point, student is, however, he or she or whatever the student should be in some kind of level. So we can add critical assessment. For example, using Snowflake for data warehousing. So something in real world storage and assessment data modeling. And where data warehousing, and also we can add comparative analysis of data model. When you now students move into fourth year, in fourth year, first semester, just like middle of fourth year, related to evaluating, also we can add something engaging peer evaluation. I think the first thing as a university student, the best thing is get the peer evaluation. Now, third year, the student has done some kind of project, mini project or something, no data warehousing, comprehensive data analysis. So using those mini project, all those things, the student can get the peer evaluation, peer review and evaluation of projects. Then moving again, the top of our Bloom's taxonomy, our framework, we can add creating in fourth year. Now, student is some kind of level, as fast remembering, understanding all those all stages. So, in year-wise alignment, we can implement project, deploy them in real-world environment. For that, we can introduce this some kind of capstone project, individual project or research project. For that, actually, we can provide real environment problems. For this case, actually, we can get the help of industry people, especially. We can collab with them. As academia, also, we can give the feedback. So we can provide real world environment problem. So student has to come across with their solution. So finally, yes, development project with Snowflake, peer review and evaluation. Also, peer review, peers they could give the evaluation, and also as academia supervisors and also external supervisor from industry, they can also provide evaluation. So you can see from the remembering to creating, initialization to creating, the final stage, remembering to creating. Now student just climb in this ladder, and finally the student is some level. I mean, the student can provide solution for real world environment. Then this is something I think you cannot see. I will share screen. Okay, so in this is something more descriptive method actually I use there. So this is my overall picture. You can see year-wise picture in there. Year 1, 2, 3, 4, and you can see in my this side Bloom's level, from remembering, understanding, applying, analyzing, evaluating, and creating. So how we can apply this in year levels? For example, year 1. Yes, in Bloom's taxonomy, what we have remembering. So we can use students, for example, that you can see the learning outcome and activity. For example, remembering student will able to recall basics Python syntax, data types, and control structure. Basic Python exercise. So as the activity, we can add basic Python exercise in Google Colab to practice syntax and data structure. Also, when you come to first year, second semester, just like that, we can add understanding. For example, we can activity load CSV file, perform basic operation. And also we can use NumPy, perform basic mathematical operation. When you come into second year, we can apply activity, clean database for apply. And analyzing, activity perform statistical method. So I have actually shared this one. We can see overall picture here up to year 4. So finally, when you come to year 4, I told you, so we can apply related to creating. Student will design, implement full-scale project, and we can do the peer evaluation. So I have shared this document with you. If you have any concern, you can add your feedback. Then, as case studies, as example, yes, we can apply any. So we have to identify our field, student field, and we can adjust little adjustment. For example, business field, deploy. We can add a case study, financial forecasting, natural science, climate solution. So we have to adjust this one according to their field and outcome and benefit. Yes. So it just, I told it's a 4-year ladder. So we can add proficiency data tool and just improve availability data science, real world problem, and also it just develop students critical thinking and creativity. So as the conclusion, why the data bloom framework matters. So it's just bridging, I told you, interdisciplinary gaps and personalized learning path, and also academia, we can innovative new teaching method. And also when you come to third level, actually student has that some kind of knowledge. So student can search for employability and just enhance creativity and critical thinking also. As academia, we want to learn for that, how to be responsible to AI use also. And finally, we have industry readiness person. Then, for future direction, I just, as a suggestion, I need something. Now we have current state, I told you we have some kind of gap. Using that again, we need something collaboration and feedback from community, especially open source community, from industry, people related to Python or whatever, KDD process, machine learning, all those things. We can add something and we can work collaborative and we can bridge, fill this gap using learning, global learning community. So my my idea is how we have transformed our university education to something more practical. So if you have any question or suggestions, you can ask me. This is my contact details. You need further contact. This is my personal email and official email and LinkedIn account.
Well, thank you very much, Hansila, for that fantastic presentation. I enjoyed that very much. And yeah, thank you for that. I think that's all the time we have. But if you want to stick around for the next session in this track, it is Causality in Mental Hygiene for Data Science with Ayla Kazim. Thanks again, Hansila.